Moving on to probability. Probability is a measurement of how likely it is that something will occur. Probability values, if you write them as a decimal, they range between 0 and 1. Or if you wrote them as percentages, it would be from 0 to 100. Something that will definitely happen has a probability of 1 or 100%. Something that definitely will not happen has a probability of 0 or 0%. Right in the middle would be a probability of 0.5 or 50%, which means it happens half of the time. We usually estimate a 75% probability or 0.75 as quite likely, and a probability of 0.25 or 25% as unlikely. When we talk about something happening, we're talking about an outcome. We mean what happens when we roll a die or flip a coin. Those are examples of outcomes. There's two types of probability, theoretical and experimental. Theoretical is when you use formulas to try to predict what should happen, whereas experimental means that you actually do an experiment. You actually roll a die a number of times. You actually flip a coin a number of times. Either way, theoretically, you'd have the total number of outcomes, the different things that could happen. If you're flipping a coin, there'd be 2 things that could happen. That would go on the bottom, in the denominator. And whatever it was you were looking for, the favorable outcome, that would go in the numerator, however many of those were. If you were doing experimental probability, you would count up the number of times you flipped the coin or the number of times you rolled the die, and that total would be the denominator. That's your number of trials, and however many of them were a success or looking for whatever it was that you were going for, that would be your numerator. So for example, let's say we toss 2 coins, and we want to figure out the probability that they are both heads. One way you can solve these kinds of problems is by listing out everything that could possibly happen. So if I flip 2 coins, I could get a tails for both flips, the first and the second. Or I could get a heads for one and a tails for the other. Either a tails first and a heads second, or a heads first and a tails second. Or both of my flips could be a heads. So that's every possible combination for flipping 2 coins and getting either heads or tails. There's 4 of them, so that's my total number of outcomes. So then my probability of flipping a heads twice in a row like that, there'd be 4 total outcomes, and only one of them is where you get a heads twice. Here's another example. An algebra class has 17 boys and 16 girls. One student is chosen at random from the class. What's the probability that the student is a girl? So your denominator is the total number of outcomes. In this case, there's 17 boys and 16 girls, which is 33 students total. And then your numerator is your favorable outcomes, which in this case is choosing a girl, and there are 16 girls. So the probability of drawing a girl from this class would be 16 out of 33. And our last example here. In a group of students, 12 ride the bus to school, 8 are driven to school, and 5 walk. 1 is chosen at random from the group. What is the probability that the student does not walk to school? There's 2 ways to solve this problem. You could look at all of the people that don't walk to school, so the 12 people that ride the bus and the 8 people that are driven to school, and that would be 20 people total out of all of the 25 that do not walk to school. So there's a 4 out of 5 chance that if you pick a student at random, they do not walk to school. The other way to do this, which is sometimes easier in larger problems, is to use the complement. The complement says if you want to find the probability that something does not happen, so the probability that the student does not walk to school, you'll do 1 minus the probability that they do walk to school. In this case, there's 5 students that walk to school out of the 25, and 1 minus 5/25 is 20/25, which still reduces to 4/5. So you'll get the same answer with either method.